this time we're going to try doing the problems from Chapter 6 on the calculator, a TI-84. 83s work. Same kind of commands go for the 89s and the inspires. So what we're going to do is, if you remember back in Chapter 2 called the Cumulative Distribution, that's where we totaled them as we go. We can do the same thing here to calculate this. We're going to use something called the normal cumulative distribution function. And in the calculator, it looks like normal CDF. Okay, so that's what we're going to look for. So what you do is you go to DSTR, which stands for distributions. So we hit second and go there. Now you'll notice that the second one is the normal CDF, and you hit enter. So we have normal CDF, and it'll come up like that. Now you go over to these problems with the Z's, and all you have to do is put in two numbers. Now, since this one is a less than, we need to think of infinity to 2.14 as our interval. Now this calculator doesn't have an infinity button, so what we're going to use instead is we're going to use minus 1 E 99 comma 2.14 like that, and we're going to plug those two numbers into the calculator. So I go minus 1 E, which is above the comma, 99 comma 2.14 parentheses, and we get 0.9838, and that's what we have for the area under the curve. Okay, now if we do the other one, the next one, we want the infinity to be on the other side. So again, we go normal distribution, go down to CDF, you put in the lower bound this time, which would be negative 1.32, comma, and now we need our numerical infinity, 1 second E to the 99 parentheses close, and we get 0.9066. Okay, and then of course if we just want between, you go distribution normal, and you just put the two numbers in, which in this case is 0.58 comma 0.69, hit parentheses, and we get 0.359. 0.359. Okay, so that's how we do the standard normal, is we just put in two numbers. Now you can do any normal, because this function, the normal CDF function, has actually 4 spots. If you don't type anything into these two spots, you automatically have the standard normal. It'll read the mean as 1 and the standard deviation as 0. If you don't, you can put in whatever you want. So for example, we can go to standard distribution, or normal CDF, and we put in our interval, 55 comma 72, the mean, which was 60 and 10, and hit enter, and we get 0.5764, rounded off to 4 decimal places. And again, if you have some time when you need the infinity, you go to the same function, and you have, since this is the smallest number, 50, up to our machine infinity, which we're going to have 1 E to the 99 comma 60 comma 10, and we get 0.8413. Alright, let's try one where this time it's for a group, so we have another variable. Now the one thing that we're going to have to do different is that when we plug it into our calculator, you have the lower limit, the upper limit, the mean, and the standard deviation. Now the problem here is the standard deviation, we don't use sigma for those, we use that formula there. So we're going to do that in this problem. So we're going to do that in this problem and put in our distribution, normal CDF 59 to 61, the mean is 60, and our standard deviation is 10 divided by the square root of 23, and we get 0.3685. And that's the only alteration that you really have to do different, is because the standard deviation has to change when you have a group. Okay? Finding the cutoffs, or what I call cutoffs for the standard normal on the calculators, not that hard, but instead of using the function we just did, we're going to use one called the inverse normal. And again, it has 3 slots. This is the area that you're trying to find, or probability, mean, and standard deviation. Now, if you want the standard normal, then you can leave these off because it'll automatically put 0 and 1 here as a default. If you want something else, then you put those there. So for example, say I want to find a cutoff on the standard normal here so that this area is 0.01. Now the way this works is that the area that goes here has to fit a picture that would look like this. So you always want to put in the area on the other side. So in this case, 0.99 for that area. Okay, so if you plug in your calculator, again, you go to distributions, go down to inverse normal this time, and I would put 0.99, and it would give me my cutoff, which is 2.326, or however far I want to write it out. So 2.33, say. And there we would have our cutoff for that one. If I wanted to have something where it's on where you had a mean of, say, 60 and a standard deviation of 10, and I wanted to cut off so that this was the bottom 25%, okay, so for this one all I would have to do is, again, go to distribution, go down to inverse normal, put in that lower part, 25, but this time I can put in 60 and 10 and get my cutoff to be 53.26. If I round it off, say 53.26, and that would be my cutoff for that lower bound like that. Not too bad.